Have you ever wondered if light is a wave or a particle? Well, the truth is, it's both. By exploring the double-slit experiment, we'll uncover one of the most mysterious and fundamental behavior of light. This experiment doesn't just reveal the dual nature of light, but it also challenges our very understanding of reality. So, what happens when light passes through two narrow slits and hits the screen on the other side? Well, the results are surprising, but before we get to that, let's set up the experiment.
Picture this. We have a light source, a barrier with two thin slits, and a screen behind it to catch the light. If light behaves like tiny particles, like marbles passing through holes, you'd expect to see two bright columns of light on the screen, corresponding to the slits, right? But here's the twist. Light doesn't always act like a particle. Sometimes it acts like a wave. What does this mean? Let's find out.
Imagine dropping a pebble in a pan and watching the ripples spread out in circles. These ripples are waves, and they have peaks where the water is highest and through where the water is lowest. When two sets of ripples meet, they interact. If a peak meets another peak, the waves combine and the water rises higher. This is called constructive interference. But if a peak meets a through, they cancel each other out and the water stays calm. This is destructive interference.
Light waves behave in a similar way. When light passes through the two slits, it spreads out, and the waves overlap, creating an interference pattern. Now, back to our double slit experiment. Instead of seeing just two bright columns on the light screen, we see a series of bright and dark bands. These bands are a result of the light waves interacting with each other.
The bright bands appear where a peak and a wave meet and reinforce each other, creating a constructive interference. The dark bands are where a peak meets a through, canceling each other out in destructive interference. But here's where it gets really interesting. If we try to observe which slit light passes through, the interference pattern disappears. Instead of the wave pattern, you just get two bright columns of light on the screen as if the light is acting like particles again.
This phenomenon is called wave-in-particle duality. It means that light and other particles like electrons can behave as both wave-in particles depending on how we observe them. This isn't just a cool experiment. It's also a fundamental principle of quantum mechanics, showing us that the universe is more complex and strange than we could have ever imagined.